All right, 6.2 is properties of rational exponents and radicals. So on this we have, it says let a and b be real numbers and let m and n be rational numbers such that the quantities in each property are real numbers. It's just a bunch of technicalities as far as that goes, not saying that it's not important because it is very important. But let's look at some of the powers, some of the properties of these powers. So right here we have product of powers, and we've talked about a little of this already, but just to have it all written down, again, make sure you write all of this page down like you do on all of your core concepts always. The definition for product of powers is that a to the m power times a to the n power is a to the m plus n. So when you're multiplying the bases that are the same, like these a's, then you will add the exponents. For example, 5 to the 1/2 times 5 to the 3/2. You're going to take the 1/2 and the 3/2 and add them together, and you get 5 squared, which in turn is 25. If you have a power of a power, so you have a to the m to the n power, you are going to multiply those powers, so you have a to the m times n. So in this case right here, 3 to the 5/2 raised to the second power, it's 5/2 times 2. So that would end up being 3 to the 5th, which you can work out in your calculator and get 243. If you have a power of a product, so we have power of a power and then we have power of a product. So that just means if I have a times b in parentheses to the m power, I can distribute that power to both the a and the b. So I can have a to the b, I can have a to the m, and then I can have b to the m. For example, 16 times 9 to the 1/2 can be rewritten as 16 to the 1/2 times 9 to the 1/2. 16 to the 1/2 is 4, 9 to the 1/2 is 3. Multiply those together and you get 12. Negative exponent rule. If I have a to the negative m power, if anytime you have a negative m or a negative power of any kind, then you are going to, I like to say, cross the line, change the sign. So we're going to drop a to the m to the bottom of the fraction, and it's going to become a positive m, as long as that a value is not 0. So we have 1 over a to the m power. For example, 36 to the negative 1/2 will become 1 over 36 to the positive 1/2, which simplifies to 1/6. And we will always simplify these. If you have a 0 exponent, anything to the 0 power is equal to 1, as long as a is not 0 itself. So if I have 213 to the 0 power, my answer is 1. I could have 1,532 to the 0 power, and my answer is 1. Now let's look at quotient of powers. Quotient of powers is kind of going to go along with product of powers. With a product of powers, we're multiplying the bases, so we add the exponents. Quotient of powers, we are dividing the bases, therefore we are going to subtract the exponents. And again, that a base cannot be 0. So if I have 4 to the 5/2 divided by 4 to the 1/2, I'm going to take those powers and subtract them. 5/2 minus 1/2, which is going to give me 2, and then I get 4 squared is 16. And the last one here, power of a quotient, similar to power of a power. Power of a product. Power of a product, I had them multiplied, so I separated. Power of a quotient, I have a and b divided to the m power. I can separate a to the m over b to the m, as long as b is not 0. So if I have 27 over 64 all to the 1/3, I can separate and put 27 to the 1/3 over 64 to the 1/3. 27 to the 1/3 is 3, 64 to the 1/3 is 4. My answer is 3/4. So again, make sure you write all of these properties down, the definitions, and the examples. That way you can always have that to look back to. Okay, so now let's look at example 1 here. Use the properties of rational exponents to simplify each expression. So if I'm going to do that right here, I've got 7 to the 1/4 times 7 to the 1/2. I am multiplying those bases, so that is going to be my power of a product, even though it kind of looks, I'm sorry, it's product of powers, I said it backwards. Product of powers, so I have the same bases. I am multiplying those together, so I can add my exponents. So I've got 7, if it will write, there we go, 7 to the 1/4 plus 1/2. Well, 7 to the 1/4 plus 1/2 is going to give me 7 to the, well, add those fractions. You can do that in your calculator, you can do that on your paper, however you wish to add those fractions, you are going to get 3/4. So that is 7 to the 3/4 power. Okay. Now we have 6 to the 1/2 times 4 to the 1/3 all squared. Well, if you notice inside the parentheses there, the bases are not the same. I've got a 6 and I've got a 4. But on the outside of the parentheses, I've got this 2. So this is going to be power of a power. I'm going to be able to distribute this. It's actually power of a power as well as power of a product put together. So I'm going to distribute it to both. So I have 6 to the 1/2. We're going to put that in parentheses for right now, squared, times 4 to the 1/3 squared. So that's our first thing taken care of. Now let's go ahead and do our power to a power. So we have 6 to the 1/2 times 2 times 4 to the 1/3 times 2. 1/2 times 2 is just going to give me 1. So I just have 6 to the first power. You don't have to write the 1 up there. Times 1/3 times 2 is going to give me 2/3. So I have 4 to the 2/3. And there we go. Now let's look at another one. We've got 4 to the 5th times 3 to the 5th, all to the negative 1/5. So we're going to distribute this power to each piece. We have 4 to the 5th, all to the, you know what, oops. Let's not do that just quite yet. Let's take care of something else first. If you notice, this is a negative 1/5. So anytime you have a negative power, we're going to put that as a fraction. So we have 1 over 4 to the 5th times 3 to the 5th to the now positive 1/5 power. So let's simplify that. It's going to take up a little bit more space since we put that as a fraction to begin with, but that's okay. So we now have, let's distribute the power, 1 over 4 to the 5th to the 1/5 power times 3 to the 5th to the 1/5 power. Now we have a power to a power here. So we have 1 over 4 to the 5th times 1/5 times 3 to the 5th times 1/5. So we're multiplying those because it's power to a power. So simplifying that, we get 1 over 5 times 1/5 is just 1, so that leaves me with 4. 5 times 1/5 again is 1, so that leaves me with 3. And 4 times 3 is 12. So I end up with 1 over 12. And there we go. All right, so moving on. Let's look at this one, D. We've got 5, and there is no power on that, so we can put a power of 1. 5 to the first power divided by 5 to the 1/3 power. That is going to be a quotient of powers. So the bases are the same, they're both 5. We can subtract the powers. So 5 to the 1 minus 1/3. 5 to the 1 minus 1/3. And when I simplify that, I am going to get 5 to the 2/3. So now I have E. So we have 42 and 1/3 divided by 6 and 1/3 all squared. So we have a quotient of powers and a power of a quotient. No, I'm sorry, we don't have a quotient of powers because the bases are not the same. But we can simplify. So we have 42 to the 1/3 squared. And we have 6 to the 1/3 squared. So now let's simplify that. And 42 to the 1/3 squared, we're going to just multiply those powers. So we have 42 to the 1/3 times 2 over 6 to the 1/3 times 2. Now, instead of just extending this all the way down, I'm going to move this over here. Please go ahead and write down your page. I'm trying to make it so you can see everything at the same time, though, for our notes. So now we have 42 to the 1/3 times 2, which is going to give us 42 to the 2/3. And then same with 6, 6 to the 2/3. Now, something that we could have looked at the very beginning was, okay, if I have the same power on both of these, 42 to the 2/3, 6 to the 2/3, basically I can work backwards with that and put 42 over 6 all to the 2/3. I can undistribute that power. If I undistribute that power, now I have 42 divided by 6. Well, I can work inside those parentheses first. 42 divided by 6 is 7. And so now I've got 7 to the 2/3 power. So that is going to be our answer. Now, if you wanted to work with that at the very beginning, you definitely could. Right here, you could undistribute the 1/3 power and go ahead and divide. You're going to come out with the same thing either way. I like to usually get rid of as many powers as I can first, but if you want to work inside parentheses and undistribute, like I said, you can do that either way. It's just a personal preference there. All right, so we're not going to look at these yet. Don't worry about writing these down. If we need to come back to them later, we will. So here's another core concept. A few more properties. We have a product property. So if I've got the nth root of a times b, I can separate that and have the nth root of a times the nth root of b. And if I have the nth root of a divided by b, then I can have the nth root of a divided by the nth root of b. So still just distributing or undistributing the nth root. And with numbers, the cube root of 4 times the cube root of 2, well, I can do 4 times 2 and have the cube root of 8, which is 2. If I had the the fourth root of 162 divided by the fourth root of 2, I can put those back in the same fraction and have the fourth root of 164 divided by 2. 164 divided by 2 is 81. So the fourth root of 81, which is 3. So these products, and that was the quotient property, these properties work forwards and backwards. You can work them either way, or you can use them either way. So let's look at example 2 here. We have used properties of radicals to simplify. So we have the cube root of 12 times the cube root of 18. They're both cube roots, so I can put them under the same root, and I can have 12 times 18. So now I have the cube root of 216. Then you can put the cube root of 216 in your calculator and you will get 6. So the thing is, you can check your work by putting this in the calculator, and make sure you get the same answer, but you have got to show this work right here, these 2 lines of work. If you do not show that, you do not get credit. So make for sure that you show all of your work that you need to be showing. B, we have the 4th root of 80 divided by the 4th root of 5. So I can put them in the same radical. I have the 4th root of 80 divided by 5. Simplify that. 80 divided by 5 is 16. So I have the 4th root of 16. And then I can put that in the calculator. And the 4th root of 16 is 2. Okay. Example 3. In example 3, write each expression in simplest form. So with that, we're going to have to be breaking a few things down here. So we have the cube root of 135. Well, let's take 135 and use a factor tree with that, in which we have done before. So 135, let's think of a number that divides into 135 that is a prime number. Well, we can, and that would be 5. So 135 divided by 5 is going to give me 27. So now I can take 27 and break it down. A prime number, which a prime number is something that only multiplies by itself in 1. So 5 only breaks down to 5 times 1. 27, a prime number that goes into 27 is 3. 3 is totally factored. It's just 3 times 1. Well, 3 times 9 is 27, and 9 breaks down to 3 times 3. So when I go over here, I'm going to break this up because I'm trying to simplify it. I'm writing it in simplest form. So I'm going to write the cube root of 3, and then there's 1, 2, 3 of them, so 3 cubed times the cube root of 5. So 3 cubed, 1, 2, 3 of those, and then 5, that's where I get the numbers underneath here. So right here, the cube root of 3 cubed leaves me with 3 times the cube root of 5. And that is totally simplified. So when we do totally simplified, we're not doing decimals, we're not trying to get a decimal, we're just trying to write it in the simplest form possible. Now let's look at another one. So right here I've got the 5th root of 7 divided by the 5th root of 8. Well, on that, 7 and 8 don't have anything in common. So if I were to break down 7, it's just 1 times 7. It's prime. If I were to break down 8, 8 is 2 times 4. 4 is 2 times 2. So I have 1, 2, 3 2's. So really that can be written as 2 cubed. So let's go ahead and do that. I have the 5th root of 7 divided by the 5th root of 2 cubed. That's how we're going to rewrite. Now I want you to look back over here at A. When I had the cube root of 3 cubed, the cube root and the cube were able to cancel because they were the same number. But over here, I have the 5th root of 2 cubed. Well, for that to be able to cancel, I would need the 5th root of 2 to the 5th. We cannot have any radicals or square roots or 5th roots. Can't have any of those radicals in the bottom of a fraction. So to simplify that, I need to be able to cancel. If I have a 5th root, I need a 2 to the 5th. Well, if you think about it, how many more 2's do I need? I've got 3. I need 5 in total, so I need 2 more. So I'm going to multiply by 5th root of 2 squared. That's going to give me a total of 5 on the bottom. With fractions, anytime I multiply something on the bottom, I have to multiply the same thing on the top. So now I have to multiply the top by the 5th root of 2 squared also. So multiplying that out, I have on the top the 5th root of 7 times 2 squared, I'm writing that all together, over the 5th root of 2, well, 2 cubed and 2 squared, that's going to be 3 plus 2 right there, because I can add those exponents. So I've got the 5th root. I'm going to go ahead and simplify that top, so that's 7 times 4, not totally simplified yet, but it's working on it, over the bottom is now the 5th root of 2 to the 5th, because 3 plus 2 is 5. All right, so let's keep working on this here. 7 times 4 is 28, so I now have the 5th root of 28 over, and my 5th root and my 5th power cancel. That leaves me with a 2 on the bottom. So I have the 5th root of 28 divided by 2. And there's my answer. Takes a little bit more work, but definitely doable. All right, let's do one of these, and we're going to do number 6 because it's the fraction. So, excuse me, on number 6, I have the cube root of 250 divided by the cube root of 2. Well, on this one, I can put those under the same fraction. The cube root of 250 divided by 2. Well, 250 divided by 2 is 125, so now I have the cube root of 125. And if you put that in your calculator, you get 5. So there are fractions that work out simple, just like that. Now, let's look at number 8 over here on the right side. I have the 5th root of 3 over 4. 3 over 4 as a fraction does not simplify. So let's separate and do the 5th root of 3 divided by the 5th root of 4. So I'm going to go over to the side over here, and we have 4. We're going to break it down to 2 times 2. So if I were to rewrite that, it would be 2 squared. So let's do that in our next step. I'm going to color code these steps so that they don't all run together for you. So the 5th root of 3 divided by the 5th root of 2 squared. Now then, looking at that, how many do I need on the bottom for it to cancel? I have the 5th root, so I need 2 to the 5th, and I've got 2 squared. Ask yourself, how many more do I need for it to cancel? If I've got 2 and I need 5 total, then I need 3 more. So we're going to multiply the top and bottom by the 5th root of 2 cubed. 5th root of 2 cubed. So on the top, I have the 5th root of 3 times 2 cubed divided by the 5th root of 2. Now, remember, bases are the same. I'm multiplying, so 2 plus 3. If I'm multiplying the bases, I'm adding the exponents. All right, so to simplify, on the top, I have the 5th root of 3 times 2 cubed is 8. And if you're not sure about that, you can put it in your calculator. Divided by the 5th root of 2 to the 2 plus 3 is 5. Now, the 5th root and the 5th power cancel. And then let's go ahead on the top and multiply 3 times 8. So I have the 5th root of 24 divided by 2. Now that's not just 24 divided by 2. So my answer is not 12 right there. That's the 5th root of 24. divided by 2, and that is totally simplified. So always, again, make sure that there's not a radical on the bottom, and make sure that everything is totally simplified. So we could go back and work those other two, but I think that you should be okay with those because they are not fractions. On these two, there's an easy fraction that worked out fine, and then there's a little bit more difficult fraction that you had to rationalize. So you may hear me talking about rationalizing sometimes. If I'm talking about rationalizing, that's right here. It's getting the radical out of the bottom of the fraction. So, example 4. On example 4, it says to write 1 over 5 plus the square root of 3 in simplest form. So, we're going to have to rationalize that because we have a radical in the bottom. I'm going to go ahead and write that problem again. 1 over 5 plus the square root of 3. To rationalize that, since it's 5 plus the square root of 3, I can't just multiply the top and the bottom by the square root of 3. I have to multiply top and the bottom by the conjugate. We talked about conjugates before when we were talking about just square roots and the i's. Remember, if I have 5 plus the square root of 3, I also have to have 5 minus the square root of 3. So that is what I'm going to multiply by. That is my conjugate. 5 minus the square root of 3 on the top and the bottom. So now, whenever I multiply, 1 times all of that is just the top, 5 minus the square root of 3. On the bottom, I now have 5 plus the square root of 3 times 5 minus the square root of 3. What we're going to have to do here is go and multiply using our box method. So we're going to do that over to the side. We have 5 plus the square root of 3 times 5 minus the square root of 3. And we are going to go ahead and box that. So now when we box this, just multiply it like normal. 5 times 5 gives me 25. 5 times the square root of 3 is just 5 square roots of 3. 5 times negative square root of 3 is negative 5 square root of 3. So remember, a lot of you have been confusing this, but remember, when you multiply, this will not be 5 minus the square root of 3. You're not adding, you're multiplying. So it's negative 5 square root 3, and it's positive 5 square root 3. So now, if I have negative square root of 3 and positive square root of 3, I get negative square root of 3 squared. Well, the square and the square root cancel, so I end up with negative 3 in that box. Now, let's take that. We still have the top of our fraction, 5 minus the square root of 3. What we just multiplied is for the bottom of the fraction. So now I have, and I'm going to write it all out, 25 plus 5 square roots of 3 minus 5 square roots of 3 minus 3. Well, if you look carefully at that, 5 square root of 3 minus 5 square root of 3, they cancel each other out. And you're left with 25 minus 3. So now on the top, I have 5 minus the square root of 3 over 25 minus 3 is 22. So you get 5 minus the square root of 3 over 22 as your whole answer there. Okay? So let's look at one more of those. I've got 3 over 6 minus the square root of 2. To rationalize that, or to simplify, I've got to get the square root out of the bottom, use the conjugate, which is going to be 6 plus the square root of 2. It's always the opposite sign. So multiply top and bottom by 6 plus the square root of 2. On the top, I get 3 times 6 plus the square root of 2. On the bottom, I get 6 minus the square root of 2 times 6 plus the square root of 2. So we're going to go box that. 6 minus the square root of 2 times 6 plus the square root of 2. Again, remember, it's similar to a Punnett square. You are just multiplying. So I have 6 times 6 is 36. 6 times negative square root of 2 is negative 6 square root 2. 6 times square root 2 is positive 6 square root 2. Square root 2 times negative square root 2 is negative square root of 2 squared, which in turn is negative 2. So let's use that over here. Let's distribute this 3 into the parentheses. 3 times 6 gives me 18 plus 3 times the square root of 2. On the bottom, I have 36 plus 6 square roots of 2 minus 6 square roots of 2 minus 2. Now we can simplify a little further. And on the top, we still have 18 plus 3 square roots of 2. On the bottom, 6 square roots of 2 minus 6 square roots of 2 cancel. So 36 minus 2 is 34. And that is our final answer. Because 3 doesn't go into 34, there's nothing else that can simplify right there. So there we go. All right, example 5. With example 5, it says simplify each expression. So we have 4 square roots of 10 plus 7 times 4 square roots of 10. Well, if there was not a coefficient out front, like right here has a 7, right here there's nothing, but that means that there's an understood 1. Like if you have 7 apples, you're going to say there's 7 apples. If you just have an apple, you're going to say I have an apple. You're not going to say I have 1 apple most likely, but it's understood. So just the same thing here, there's an understood 1. Well, if I'm going to simplify that, you're just adding 1 plus 7, and that's going to give you 8 apples, or 8 fourth roots of 10. And 10 does not simplify. If I do the factor tree with 10, it's 2 times 5. That's all it simplifies to. Nothing that would help me with a fourth root. So we're going to leave it as is. 8 times the fourth root of 10. All right, the next one. I've got 2 times 8 to the 1/5 plus 10 times 8 to the 1/5. Well, the inside, the 8 to the 1/5, is the same on both. I've got 2 apples plus 10 apples, so that's going to give me 12 apples, or 12 times 8 to the 1/5. On this one, see if it'll simplify. So if I take 8, it's 2 times 4, which is 2 times 2. So 1, 2, there's 3 of them, not 5 of them. So again, that is totally simplified. 12 times 8 to the 1/5. All right, one more of these. I've got the cube root of 54 minus the cube root of 2. Well, that's a little bit different because they're both cube roots. But I've got 1 here and I've got 1 here, but they're not the cube root of the same thing. I've got like 1 apple minus 1 banana. I can't subtract that. What I can do, though, is I can simplify my cube root of 54. So let's go over here and take 54 and make a factor tree with it. So 54, I want to try and see how many 2's are in there. So because the other one has a square root of 2. So 2 times, so if I take 54 and divide by 2, I get 27. 27 divided by 3 is 9, and 9 divided by 3 is 3. So if I rewrite the cube root of 54, I'm going to rewrite it as the cube root of 3 to the, let's see, there's 3 of them, so 3 to the 3rd times the cube root of 2. Because there's this this 2 that's left over right there. Now the rest of it I can write as minus the cube root of 2. That one comes from right there. Excuse me. So now with my next step, the cube root and the cube power cancel, and I have 3 cube roots of 2 minus the cube root of 2. Well, remember, if there's no coefficient, it's an understood 1. So 3 apples minus 1 apple. So they were the same thing, it was just written as a different power. 3 minus 1 is 2, so I now have 2 cube roots of 2. And that is totally simplified. So there's definitely some thinking that's going to have to go on with these, but they're not difficult if you do sit down and think about them. All right. We are going to skip over these. These are just some extras. Let's look now at example 6. So in example 6, it says, again, to simplify. This one has variables, where before we didn't really have any variables. So we have the cube root of 64y to the 6th. Let's go ahead and get a factor tree going. 64, well, we know it's even, so let's divide by 2. 64 divided by 2 is 32. It's even, so let's divide that by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So I have 1, 2, 3, 4, 5, 6. I can rewrite over here as the cube root of 2 to the 6th, y to the 6th. So 64 is written as 2 to the 6th because when I did my factor tree there were 6 2's. Let's now simplify this a little further. I can take this and separate and take it as the cube root of 2 to the 6th times the cube root of y to the 6th. When I do that, when you take the cube root, if I take the cube root of 2 to the 6th, then I can divide those exponents. So 6, I can rewrite that as 2 to the 6 divided by 3 times y to the 6 divided by 3, and they divide evenly. So if I have 6 divided by 3, that's 2, so that's going to be 2 squared times, and again 6 divided by 3 is 2, so y squared, which is going to leave me 2 squared is 4y squared. And that one is totally simplified. So when you are simplifying radicals, remember you can divide or rewrite it as a fraction. What goes on the inside as the power goes up top, and what goes out front goes on the bottom. So you're just undoing the same stuff that you did in the previous section. So now B, let's try that one. We'll draw a line down here to separate these. Maybe. There we go. Excuse me. So if I have the 4th root of x to the 4th divided by the 4th root of y to the 8th, let's separate that. And let's say we have the 4th root of x to the 4th divided by the 4th root of y to the 8th. Now let's rewrite this as a fraction, and we will have, since we're dealing with fractions, I'm going to use a different color so we don't get lost. We will have x to the 4 over 4 divided by y to the, remember the power goes on top, the radical or the root goes on bottom, so 8 divided by 4. Now, simplify. Just reduce your fractions. 4 divided by 4 is 1, so that leaves me with x. 8 divided by 4 is 2, so that leaves me with y squared. So I have x over y squared. Now then, we have an example 7. Write each expression in simplest form. Assume all variables are positive. When you see all of that, just think simplify. Simplify, simplify, simplify. That's what we're looking at. So if I have the fifth root of 4, a to the 8th, b to the 14th, c to the 5th, all I want to do is simplify. And since it's a fifth root, I want to get groups of 5 in the beginning and then the leftover at the end. So 4, I can rewrite 4 as 2 times 2, or 2 squared. Well, that's not going to help me with the fifth root. So right here, I'm going to have a fifth root of everything that is simplified times the fifth root of what cannot be simplified. The 4 cannot be simplified. A to the 8th. Well, that can be simplified. So if I take 5 out and I put a to the 5th here, 8 minus 5 is 3, so I'm going to put a to the 3rd in the other group. B to the 14th. Well, I can take out 10 of those and put in what can be simplified, because 10 divided by 5 comes out right, and I have 4 left over, so b to the 4th goes in the second group. C to the 5th, that's going to go in the first group, and none left over in the second group. So now when I rewrite this, I can rewrite this as a to the 5 over 5, b to the 10 over 5, c to the 5 over 5, times, now this last part is going to stay as is, the fifth root of 4a cubed b to the 4th. The first is what can be simplified. So now I have 5 over 5 is 1, so I just have a. 10 over 5 is 2, so I have b squared. 5 over 5 is 1, so I just have c. And then I have the fifth root of 4a cubed b to the 4th. And there's my answer. So when you have something like this, all you're going to do is separate it into two groups. What can be simplified and what cannot. Okay, let's look at another one of these. I have x divided by the cube root of y to the 8th. So on this one, if I have the cube root of y to the 8th, well, how many groups would I have here? Because remember, you have to rationalize. You can't have a radical on the bottom. Well, if I had the cube root, and I'm just going to write this to the side, if I had the cube root of y to the 6th, that would divide evenly, 6 divided by 3. Then next one would be the cube root of y to the 9th, if I'm looking at groups of 3. Well, I have y to the 8th. So how many more would I need to make that a 9? Just one more, because I have 8 already. So I'm going to multiply the top and the bottom of this fraction by the cube root of y to the 9th. Okay, when I do that, I get x times the cube root of y to the, no, I did that wrong, I'm sorry. Hang on just a second. I wrote that wrong. I'm thinking 9 total, so that should have been, I apologize for my mistake. That should have been the cube root of y that I'm multiplying by. So I get a total of 9 whenever I'm done. So I'm just multiplying the top and the bottom by the cube root of y. And that would, if you need an exponent, that would be y to the first power. So on the top, I get x times the cube root of y divided by the cube root of y to the 8 plus 1, which in turn will be y to the 9th. So to simplify this, I have x times the cube root of y divided by the cube root of y to the 9th. I can rewrite that as, on the bottom, y to the 9 divided by 3. The top will stay the same, x times the cube root of y. And here, because I ran out of room, I have x times the cube root of y divided by 9 divided by 3 is 3, so y cubed. A lot of simplifying. Don't skip steps. If you skip steps, you're going to get confused, and I don't want you confused. So please do not skip steps. Let's look at one more of these. If I have 14 times x times y to the 1/3 divided by 2 times x to the 3/4 times z to the -6th, and I am supposed to simplify. Well, if I look at my coefficients, 14 and 2, I can take 14 and divide by 2, and that's going to give me 7. Now, if I put an exponent on that x, that's going to be a 1. Remember, when you're dividing bases, you subtract exponents, so I'll have x to the 1 minus 3/4, because I have x to the 3/4 on the bottom and x to the 1 on the top. There's just a y on top, so that's going to be, let me put this in parentheses for you, that's just going to be y to the 1/3. And then on the bottom right here, I have z to the -6th. If it's a negative exponent, you cross the line, change the sign. So I'm going to move that up to the top. And it's becoming positive, so z to the +6th. Now let's just simplify. So I have 7 times x to the, well, 1 minus 3/4 is 1/4. Y to the 1/3, z to the 6th. And we're going to leave it just like that. Nothing else to simplify. So when you are dividing bases that are the same, you subtract your exponents. When you have a negative exponent, you move it up to the top. Or if it's on the top negative, you move it to the bottom. All right, example 8, our last example. Perform all indicated operations, that should have an S on it, assume all variables are positive. So if I have 5 square roots of y plus 6 square roots of y, that's just 5 apples plus 6 apples. That's going to give me 11 apples, or 11 square roots of y. That one's done. Easy peasy lemon squeezy. Let's go to B. So we're basically putting everything that we've learned in this section together. We have 12 cube roots of 2z to the 5th minus z cube roots of 54z squared. So we're going to have to rearrange a few things because nothing is the same except my cube roots. So if we were to simplify some stuff here, I have 12 times the cube root of 2 times the cube root of z cubed times the cube root of z to the, well, you're looking at that and you're going, no, you wrote that wrong. That's z to the 5th. Well, what I did is I took out what I needed. So if I have a cube root, I want z cubed. Well, I have 5 total, and I took 3 out. I've got 2 left over. Minus, let's look at the second part here. There's a z out front. I have got a cube root 54. Well, let's go to the side and break 54 down. 54, remember, is 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. So if I'm going to rewrite this, I've got the cube root of 2 times the cube root of 3 cubed, because there are 3 of them there. And then I've got the cube root, so times the cube root of z squared. Okay, so in blue, let's go simplify what we can. I've got a 12, so that one's taken care of. I have right here the cube root of z cubed. So the cube root and the cube cancel. That leaves me with z. So this is taken care of. This is taken care of. Now I have left my, so times, the cube root of 2, and I'm going to put them back together, z squared. So that came from the cube root of 2 and the cube root of z squared. Minus, I've got a z out front, right there. I've got a cube root of 3 cubed, so the cube root and the cube cancel and leave me with a 3. It is written backwards right now. We will fix it in a minute. And then here I have the cube root of 2 times the cube root of z squared, which is going to give me the cube root of 2z squared. So now, if you look, you have the cube root of 2z squared and the cube root of 2z squared. And I have 12z, and written backwards I have 3z. So 12z minus 3z, because of my minus right there, 12 minus 3 is 8z times the cube root of 2z squared. And there's my answer. A little bit of work that had to be done. You know what? I did it again. That's not 8. That is 9. 12 minus 3 is 9, not 8. I never claimed to be perfect. I'm sorry. Okay, so 9z times the cube root of 2z squared. The key is when you make a mistake, figure it out and fix it. All right, so there we go with 6.2.